water. Heat capacity, vapor pressure, volume and density, cohesion, adhesion, surface tension, viscosity. Student, today I'm going to go through all these terms and explain. Let's start. Water, heat capacity of water. This word, what is heat capacity? Let's demonstrate an example. In here, you find that one day, if you're under the sun, say in one hot summer day, you put a bucket of water and lay a piece of brick, both under the sun for 4 hours. Then you touch the brick and you touch the water. What will you find? They both having the same amount of energy, so they both been under the sun for 4 hours. So would the temperature be the same? Let's find out. You touch the brick will burn your finger. But you touch the water will just look warm. So what does that mean? That means seems that you inject with same amount of energy into two different substances. One substance absorbs more heat, other substance doesn't seem to heat up as much. So don't have an assumption that if you put it under the same amount of heat of two different substances, they will have the same temperature. That's not the case. And particularly in water, it can absorb a lot of heat, and the change in temperature are very little. As in this case, if you you put the same amount of heat in a brick, very hot. Same amount of heat onto water, only lukewarm. Now, let's talk about the specific heat capacity formula. This formula is to calculate every different substance of that substance, how much, when you put the heat in, how much it will heat up. I repeat, specific heat capacity is to measure on different type of substance. Of that substance, if you put the heat in, how much it will heat up. Now I show you an example. If there is 1 gram of a substance, and now let's what's the room temperature now? I think now it's about 24 degrees outside, nice and cool. And I want this substance to go to 25 degrees. 1 degree change, increase 1 degree more. So I want this 1 gram substance increased by 1 degree. Now, so how much energy I have to add in to input it so that to make this 1 degree change? That is the specific heat capacity of the substance. Unit, joules per gram per Kelvin. So student, look at this unit. This J is the energy you input to make this substance temperature change by 1 degree. 1 gram per Kelvin. Temperature K. So please know this unit. Now let's take another example. Now I have a different substance. I take a 1 gram of this substance I also want it to raise temperature by 1 degree more. Now this different substance, I want it to increase temperature by 1 degree more. How much energy I have to inject? And in this case, it shows that, I have to have more energy. I have to inject more energy to make this 1 gram of substance to increase 1 degree more. So this substance is, I have to put more energy than the previous substance. Do one more. If I have the third substance, I take 1 gram of it, and I want it to raise the temperature by 1 degree higher. How much energy I need to inject? How much energy I inject? In this case, I have to inject more energy. I have to inject more energy to make this substance increase by 1 degree. So this to demonstrate, even they all are 1 gram of different substance, I want all raised by 1 degree, but I have to inject different amount of energy to make this change. Some will be easy to be done, some will be easy to be done, some will be very difficult to be done. And this definition of specific heat capacity. Now let's look some example. Now I have a list of chart of different substance. You see the energy. They are listing in the form of this energy. See, this take 4.18, and then it going less and less and less, and this 0.14 energy. And how's this work? Let's see. Mercury. Mercury. If I want this mercury to raise this 1 gram of mercury, I want it to heat up 1 degree. I just need to inject a little bit of energy. I can do it. How much? I just need to inject 0.14 joules, and I can achieve this 1 degree rise. Let's look another. Aluminium. Aluminium is harder. Aluminium, I want 1 gram of aluminium. I want it increase 1 degree more. I have to inject 0.9 joules of energy. So in this case, this is harder. I have to put more energy, 0.9, to make it 1 degree more. How about water? Water is extreme. Water, I have to inject 4.18 joules of energy. That means I put, that is 40 times more. That is a lot of energy to make water, 1 gram of water, to raise 1 degree more. So water is very hard to heat up. Water is not easy to heat up. Why water is so hard to be heat up? Because of hydrogen bond, I will talk. Because of this hydrogen bonding, they are in a very tight bond. The hydrogen bond is a very strong bond. It is not easy to vibrate hydrogen bond. They're too strong to be vibrate. So that is the reason. Water in heat capacity. So we know water can absorb a lot of energy, and the temperature 1 degree rise is not easy. So that's why under the hot sun, brick heat up easy. Water doesn't heat up easy. And this is the reason. So you have such large heat capacity of water. It can have a significant moderate effect on temperature. So people like to live in the coastal area in New South Wales because the temperature change are between 17 to 23. Inland in Australia, the temperature vary greatly, 0 degree to 40 degree. So in inland area, when it's hot, very hot, when you just like you are in the piece of brick. When you're cold, you are very cold. In coastal area, you are with the water. You are by the water. Just like you have a bucket of water next to you. When you're hot in hot day, you are moderately hot. In cold day, you are moderately cold. That's what I mean by moderating effect. So now you learn the word heat capacity of water. So remember, every substance, they heat up differently. When you put in the same amount of heat, you don't expect they will all have same temperature. That's not the case. So based on the heat capacity of each substance. Now I'm going to talk the next topic, evaporation. What is meant by evaporation? Evaporation means substance turn from liquid into gas. Substance turn from liquid into gas. When substance turn into gas, that is one very interesting phenomena. When any substance from liquid turn into gas, they absorb heat. That is something that you don't expect. So when any substance you turn to gas, you make the environment cooler. That's why you're sweating. In hot day, you sweat. So when you sweat, the sweat turn into gas, you absorb your body heat. So if you not believe me, you think about one day you go for swimming. You find that when is the coldest time? The coldest time is when you come out from water. Because when you come out from water, the water will absorb your body heat to turn the water into gas. So you will absorb your body heat. You will absorb your body heat and make you cold. That's the reason. So now let's look more about evaporation. Liquid turn into gas. Scientists have to find a way to measure liquid turn into gas. And all substance, when from liquid turn into gas, they are different. Don't expect they all the same. They will be different. So scientists try to make a measurement. And this measurement is called vapor pressure. Vapor pressure, kPa. How does vapor pressure work? The theory is very simple. Let's look on to the first chart. If they put an ethanol, say at 20 degrees, at 20 degrees, ethanol was and in this bottle of ethanol, they put a pressure gauge. And this, when they turn some of it turn into gas, they will start to pushing the gauge. they will pushing the gauge on the opening. So this pushing raise the pressure on the gauge, that is indicating. Now, when they put another substance, ether, under the same temperature, 20 degree, this substance, they also turn into gas, but seems to be they more turn into gas. They more turn into gas, and they push the gauge more harder. They push the gauge a lot harder, so the pressure is higher. So this to prove one thing. Different substance, they become from liquid turn into gas. Don't expect they will have the same pressure. One will be more pressure than the other. So they measure it by kPa, vapor pressure. And on the table, I show a chart. This chart shows all substance under the degree of 20 degree. How they react by some will have a very high push like ether. That means they really want to be gas. And some substance, mercury, they don't push at all. It seems that they don't want to be gas. Very few will be gas. So this vapor pressure is a measurement. How is the liquid turned into gas? How much would that liquid want to turn into gas? Now, let's explain about why liquid would turn into gas. Vapor pressure is depend on the intermolecular force of the substance. Well, have we learned this word before, intermolecular force? Yes. Water. Water have a hydrogen bond, and so they have low vapor pressure. What does that mean? Water, between water and water, H2O, they are polar. This polar molecule with another polar molecule, between them are intermolecular force. This intermolecular force is hydrogen bond, which is very, very strong. They not easy to be break, and they don't want to become gas that easily. You want it to become gas? Yes, 200 degree, 150 degree, you can. Lower than that, these bonds are too strong. So, remember our early topic. This hydrogen bond affected because of this polar molecule. It contains the OH, NH, or FH group. Now, let's look on. So that means water have a large heat vaporization. You have to put a lot of heat to vaporize water. Now, if you look on to see, you see on the chart, water 2.34. They don't want to be gas. Okay, now let's look on other substance. Ether, pentane, chloroform. On the upper chart, you see on the box. What does this mean? This means this type of substance, they want to be gas. Some on the top one, ether, they really want to be gas. Why would they want to be gas? Because the attraction force, the intermolecular force between the molecule are dipole or disperse force. What is dipole? they are a polar molecule, but it's a partial, slightly polar, like a small little magnet. Small little magnet, yes, they do have attraction force in between. They do have attraction force in between. Are they strong like the early one? No way. So this partial attraction make them to become dipole polar molecule. So they will lot easier to turn into gas. And when it comes to the ether, this is the dispersion force. What's dispersion force? Dispersion force is those molecules are non-polar molecule. Non-polar. Between non-polar and non-polar, that is the attraction force are dispersion force. Dispersion force is a very weak force. Tiny bit of heat, they turn into gas. Room temperature, for them, too much vibration of heat. They like to become gas. So, ether, you can see they have a very high pushing, high vapor pressure. So, this again talk water don't want to become gas. Why? Again, intermolecular force, hydrogen bond. Of this vapor pressure, now we just examine is at 20 degrees. What happens if they at 40 degrees? You look onto this chart. 40 degrees, let's take pentane. Pentane at 20 degrees, the vapor pressure is 50. But when you raise 20 degrees more, it double. So you have double the pushing. What happens? You increase another 20 degrees. Wow, this is become 200 vapor pressure on pentane. What does that mean? They have big impact. You see some aerosol can, they say do not put heat. Because what happens if you raise temperature by 20 degrees or 40 degrees? 40 degrees for you may be nothing, but 40 degrees for this volatile substance, pentane, the vapor pressure will increase from 50 to 200, and the can cannot sustain. What's mean by cannot sustain? That means it will blow up. Explosion. That's why never heat up the aerosol can unless you know what is the substance inside. But I tell you what, most of the time those substances inside are volatile substance. They easily turn into gas. So that means you raise temperature by 10-20 degrees, you increase the pressure by a lot, 10 times, 20 times. So very dangerous. Do not do it.